Hello everyone, this is our ninth instructional video. So for Math 1, hopefully you guys are having a great week. This is going to be for Wednesday's lesson. I don't have any updates other than hopefully I get to see you tomorrow during our live sessions on Thursday from 9:30 to 11:30. You want to make sure to join in on Google Hangouts. If you missed any of the previous ones, all the links are in the resources tab in Google Classroom under live session. So please check out those recordings. And that's about it for me. Make sure you grab your packet or bring out your computer, have the document up with you. You can also take your own notes in your own notebook as I go through this video. The idea is that this learning is for you. You do what's best. There is also a text-to-speech function in Google Docs. So if you're interested in that and you don't know how, you feel free to message me. I can explain how to do that. And that's it. Let's get started. I'm going to share my screen right now. And I'm going to do that. Let us begin. Okay, so for today, I'm going to just move this up. We're going to be kind of putting things together. It's going to be a fairly quick packet, but our objective is to make predictions using the line of best fit algebraically, okay? Let me just check that this is working. Okay. Oops. Why won't this work? Okay. So previously in our lesson, so what I write in red, you don't have to write down, but if I write in purple, please make sure you're taking down your notes. That means it's really important. Previously, we were thinking about what a line of best fit is. And that's basically a linear model we use to represent a scatter plot, to represent the data on a scatter plot. Data set on a scatter plot. Okay, and we're figuring out how we can create equations based on this linear model and using that equation to make predictions, to make good guesses based on this data. So what I'm going to be doing today is I'm going to go over this quick mini lesson. The answers are already there in red, but I'm going to explain how I got those answers. And then I'm going to go and we're going to work on this practice problem together. You're going to try it on your own first, and then I'll go over the answers in my video. And after that, your goal is to finish your exit ticket. This is something you'll do by yourself. And then when you turn in your packet, that'll be in Google Classroom. And then I'm going to go over briefly our schedule for the next 2 weeks, 3 weeks. Okay? So let's get started. So we have this problem here. I'm going to move this down so you guys can see that as I'm gonna move that down a little bit, make that a little bit smaller. Amazing, right? Technology. Fantastic. Okay. So in this case, I'm going to read out the example. So you have noticed I'm going to write down or highlight our instructions in green moving forward. That way you guys know exactly where to look. So this example, if you read it, is a scatter plot that shows how many pieces of candy are in a jar based on the number of students. So based on this data, how many pieces of candy will there be when there are 30 students? This is going to be the situation, and there is our question, right? So there is a candy jar. If you notice here, we have a candy jar. Our independent variable is our number of students. And our dependent variable is how much candy pieces are in a jar. We see that there's some data points, as you can see by these dots here. These are data points that was collected. Oh, that's not a data point. And we also have our line of best fit here. Now, we're trying to figure out how many pieces of candy there will be when there are 30 students. So in this case, I always want you to think about what's your known and unknown, all right? Something that you do know immediately is that there are 30 students. Okay, this is from your information. We're trying to figure out, based on this question, how many pieces of candy are there when there are 30 students. So our known is 30 students, which, if you notice, is our x value. That's why I wrote x value here. Our unknown, something that we're trying to figure out, is the number of pieces of candy, which is our y value, when there are 30 students. Okay? So when I am looking to solve this problem, that's the first question that you want to ask. First, this is just another way to organize information. And a lot of math is actually your ability to organize information and figuring out what you need to do to get to your answer. The next step that you want to do is to find the equation for a best fit line. Thankfully, in this scenario, I already drew out the best fit line for you. So what you really need to do is now just figure out a couple of points, or you need to figure out the equation. So we know the answer is y is equal to negative 6x plus 300. But I'm going to break it down for you. How did I get this equation? Now, in this case, because the pattern is linear, we're going to use a linear model. If you guys recall, the linear equation formula is y equal to mx plus b. All right. Now, we know that our y, maybe I should use a different color. Y represents what? It represents our candy in a jar, and our x represents our number of students. Now, what we need to figure out is our m and our b. This basically, our m is our slope or our rate of change. I don't know why they use the letter m. Mathematicians are kind of weird sometimes. And we got to figure out our y-intercept, which for those who joined my live session on Tuesday, remember that it's the point where the line crosses the y-axis. Okay. So this is important information, so I'm just going to move that over, however, to the side. That's going to be what we are looking for here. Okay? That's for number 2. Now, how do we figure that out? So in this case, we got to figure out 2 things, right? And this one you might want to write down in your notes on this document or on your packet, okay? So we want to figure out our slope and our y-intercept for this line of best fit. I wouldn't worry about the data points at this point because we are using a linear model. We're using our line of best fit. All you want to worry about is your line of best fit. So don't even worry about the data points. The easiest way is actually finding the y-intercept first because that's super easy, right? Where does the line cross the y-axis? We know that the y-axis is here. So where does the line cross it? We notice that it crosses at 300. So our y-intercept is actually going to be 300, which is why we have plus 300 here. So how did I get negative 6? So when I want to figure out slope, I want to figure out the rate of change. There's a couple ways that we can do this. What I'm going to do first is actually just figure out 2 points. So what I'm going to do is maybe move this actually. I'm going to move this up here. That way I have more space to actually solve for it. So I'm going to write down my answer here, but to solve that, I'm going to figure out first, I'm going to find 2 points. So the first point, I'm always just going to use my y-intercept. It's 0, 300, 0, 300. And then I'm going to use another point. I'm going to use this one. This one is 10, 240. Okay, this point here is 10, 240. If you notice, I didn't use an actual data point. I didn't use a black data point that's already on the graph. I just found where the line crosses a whole number, okay? So don't feel like you have to use a data point. I often see a common mistake that students make is that they want to use a data point, but you want to find a way that find a number or a point that's easy to calculate. And I can show you why this is such a great number. So you're going to find the rate of change. How do we get from 300 to 240? I'm going to subtract the second number from the first number, and you get negative 60, which makes sense because 300 minus 60 is 240. And here, I'm going to do the second number minus the first number, which is just 10. Okay, so we got our two numbers here. This is our y, that's our x. Negative 60 is our change in y. Our 10 is our change in x. So we know that our change in y, oops, that should be purple. Our change in y is over change of x. The triangle is just a change symbol. It's going to be negative 60 over 10. So what does that mean? It's saying that every 60 candy pieces, like we lose 60 pieces of candy for every 10 students. This is what our rate or slope is telling us. It's saying that there is a general pattern where every 60 candy pieces that get eaten, that's usually done by 10 students. Okay, so 60 pieces of candy disappear per 10 students. Or the way we can say it actually, if we simplify our fraction, is that every 6 pieces of candy, we say we lose 6 pieces of candy because it's negative, we lose it. We lose 6 pieces of candy for every student. That is what our slope is telling us. Okay? Because we figure that out, we can actually now write out our equation, which if you noticed, I'm going to delete that, is exactly that. Y equals negative 6 because that's our m, x plus 300. That's how I got those pieces. I'm going to highlight it just so you know when you look at this where I got the numbers. So I'm going to do 300 in pink. So that's how I got 300. And I'm going to do the other color in light green. That's how I got my slope. And obviously, y and x represents our independent and dependent variable. That's going to be really important to understand because I'm going to point that there so you know that's where I got it. It's really important because when we're trying to figure out what we don't know, we need to figure out what we do know. And that's why number 1 is really important in problem solving. So when I'm trying to solve the question, based on this data, how many pieces of candy will there be when there are 30 students? I already know basically that x is equal to 30 at this point. So I'm trying to figure out when x is 30, right? What is my y value? So if you look at this equation, basically I plugged it in. So because I know x is 30, I can plug in x to solve for y. Maybe I'll use that in a different color. Once again, because I know x is 30, which you can look at number 1, I can plug in x to solve for y. And that's basically what I did here, right? So if our equation is y equals negative 6x plus 300, I plug in 30 into the equation. And then if I solve that out, it's negative 180 plus 300. And that's how I got my answer, 120 pieces of candy. Okay, so that's for page 1. And that's how I got that answer. All right. I'm going to delete that because I just rewrote what's already there. But I'm going to shoot an arrow here. So that is a lot of information. Take a moment and pause and think about how each step you take to solve these kinds of problems. Um, think about how you would go about it yourself. Okay, so feel free to pause this video, take a look at my notes, and then we're going to move on to page 2. Okay. Okay, cool. If you do have any questions after you unpause the video, feel free to comment below on my channel or Google Classroom to ask me how I went through this. Why do I have 3 steps? Like, what does it mean to figure out the equation? What is a known and unknown? What do you mean by plugging it in? If you have any of these questions, feel free to message me and so I can answer that. Okay, but let's move on to page 2. So right now we have a problem here where it's a group of friends recorded how much time it took to bike around the park. The graph below shows the data they collected. So basically, if we were to use our imagination, there is a park, right? And a group of friends decided to go on a bike. This is before COVID-19. They decided to go on a bike ride around the park, right? So they're counting how many laps they took and how much time it took. Okay, and you do this multiple times. A lap is basically one circle around the park. If you guys didn't know already. Okay, so what is our question? Our question is, how much time would it take if you took 13 laps around the park based on this data? Once again, we have our data points around here. We have our line of best fit. And 13 laps is basically off the graph. So how can we use algebra or an equation to figure this out without having to draw it out on the graph? And that's the cool thing about using a linear equation, is that you can do calculations without having to draw things out. So it's like actually a shortcut. That's why I'm teaching you this, is so that you guys know a way to solve problems in a fast manner. So pause the video, try to answer 1, 2, and 3 by yourself. And when you unpause the video, I'll move ahead and give you guys the answer. Okay? So hopefully you guys are working hard during this time. And welcome back. Hopefully you guys did take the time to answer this on your own. That way you can double check. I always say the only way to learn math is to do the practice problems, okay? So I'm just gonna work through this fairly, not quickly, but like as if I was solving it. And if you have any other questions, feel free to message below or comment below. So my first step is, what's my unknown and known? So I know that there's 13 laps. Let me use purple. So I know my known is that's 13 laps, which is my x value, and my unknown is my time, which is my y value. Then I need to figure out number 2, which is figure out the equation. I know that my equation is y equals mx plus b. Y is, erase that. Y is time, x is laps, and I need to figure out m and b. B is my y-intercept, and m is my slope. I'm going to find my y-intercept first because that's really easy. It's wherever it crosses the y-axis. My y-axis is right here. I notice that it crosses at 1, so my b is 1. Now I'm looking for a slope, so what I'm going to do is make a table, figure out 2 points, right? I'm going to use 0, 1 because I already know my y-intercept is one of the points on the line. And then I notice that I can use that point, which is going to be 2, 2. What's my rate of change? This one is going to be change in y is 2 minus 1. that's going to be 1. And then my rate of change here, it's going to be change of x equals 2 minus 0, which is 2. They're both positive. So it's going to be my change in y over change of x. So it's going to be 1 over 2, positive. Let me just move this over. So I know that's how I solved it. So I got my equation. So my equation is going to be y equals 1 over 2x plus 1. And now I have to solve the equation. So I know that my x is equal to 13, my bad, and I'm solving for y. So basically, I just plug in x 1/2 times 13 plus 1. That's going to be a decimal. So that's going to be 6.5 plus 1, because half of 13 is 6.5. And that's going to be 7.5. And I know it's going to be minutes. So that is my answer. So I know now, based on this scatter plot and the data that this group of friends collected, that if I took 13 laps around the park, it's very likely, I'm making a very good guess, that it probably took me 7.5 minutes, which is actually really fast. So I'm guessing the park isn't that big. But yeah. Yep. So hopefully this was a little bit helpful in figuring this out. This is a lot of basically everything we've been learning kind of put together. Your next step is to finish the exit ticket, which is exactly the same, except just a different situation. Take time to finish that and turn that in. So just a few heads up, I'm going to go over some things to expect. So today is our Wednesday, right? So I will be uploading this lesson, and by this point, you should have finished your mini QPA 1 and mini QPA 2. If you haven't, please get those done. Tomorrow on April 9th is our live session, and on Friday, I will be posting another lesson. If you notice in green, I have your deadlines as well. So you want to be done with lesson 6, which is last Friday's lesson, by this coming Friday. And just take a moment to read what is expected by next week. I will have 3 videos next week, which will be review videos posted, just so you can really have time to finish those mini QPAs and also understand the material that I've been teaching. And the week after that is spring break, so there won't be any videos posted. And that following week, we're going to be doing our our capstone QPA. And we'll be working on that, wrapping up the month of April. And hopefully I will be able to see you in May. But all things considered, we are also prepared to move ahead with online learning if that's not the case. So that's it for me. Just another reminder, right? Make sure you do your exit ticket and turn this assignment in by, you have 1 week to get this done, okay? Hopefully you guys are doing well. Would love to see you in the live sessions tomorrow. And now I'm just repeating myself, so I'm just gonna wrap this all up and say goodbye. Hopefully math was impossibly easy, and yes, be very well. And I'm going to go back to this and finish recording.